Well, welcome everyone. On behalf of everyone at the Center for Brain Health, I want to welcome you to our Frontiers of BrainHealth, where we take a deep dive into the most exciting developments in brain research. I'm Dr. Julie Frattantoni, and I'm a cognitive neuroscientist and the head of research integration and partnerships here at the center. And I want to let you know that this talk is going to be recorded. We do have a virtual audience, and there will be time for questions at the end. So if you are tuning in virtually, please use the Q&A function to drop your questions in there. We'll get to as many of them as we can. For those of you who don't know much about us, the Center for Brain Health is a cognitive neuroscience research center that is part of the University of Texas at Dallas. And we have dedicated the last 3 decades to exploring neuroplasticity and the brain's amazing lifelong potential to get stronger and work better. So now I get to introduce our speakers for today. So Dr. Caroline Leaf is a communication pathologist, audiologist, clinical and research neuroscientist, specializing in psychoneurobiology and metacognitive neuropsychology. Since the early 1980s, she has researched the mind-brain connection, the nature of mental health, and the formation of memory. She was one of the first in her field to study how the brain can change, neuroplasticity that we talk a lot about, with directed mind input. And Dr. Leaf is also the host of the podcast Cleaning Up Your Mental Mess. She has published in scientific journals and is the author of 18 best-selling books, including Cleaning Up Your Mental Mess, How to Help Your Child Clean Up Their Mental Mess, Think, Learn, and Succeed. Her passion is to help people see the power of the mind and teach them how to control their thoughts and emotions and to learn how to think and find their sense of purpose in life. So we're in for a real treat with her. She is also joined today by Charles Wasserman, who has a master's in psychological sciences with a concentration in behavioral neuroscience. And with a graduate certificate studies in the neurobiology of language from the University of Connecticut, and also a bachelor's in psychology from the University of Hartford. And he is currently 3 weeks about to finish up his coursework for a AUD, Doctorate of Audiology, and then we'll be going into his residency to continue just doing really important translational clinical research work and marrying those two together. It's been really fun to get to know them today as they've been here. So his research interests include auditory neuroscience, neuroplasticity, bio and neurofeedback, and perception of music. His research mainly utilizes physiological measures, specifically EEG, ERP, EMG, as well as behavioral experiments to look at how the brain processes and codes complex rhythms and how music can be used as a non-invasive form of therapeutic stimulation. So without further ado, welcome them to the stage.
Good morning, everyone. Thank you so much, Dr. Frattantoni. It's wonderful to be here, and this amazing work that's being done here. It's so exciting for us. I've been in the field for close to 40 years now, and I'm so excited to be here and sharing what we do with you, what we've done. Charlie's part of our research team, and he's amazing. I think we've got so much to share, so to squash it into this 45 minutes is going to be an exciting challenge, but we're very, very excited to be here with you. Charlie, do you want to say hi?
Sure. So this sort of story started about 7 years ago now, down in Charleston, South Carolina. So if we think back to before the pandemic, we were all walking around breathing without masks. Dr. Leaf and the physician of the practice, Dr. Robert Turner, at that point said, we've got a whole bunch of these individuals who are going through getting diagnosed with some kind of neurological condition, and we can do standard medical intervention, but there's not really much addressing their mental health well-being or just the pattern of passing through that obstacle of that diagnosis. And so, having heard about Dr. Leaf's work, two of them sort of teamed up to do a little pilot study. So in 2018, 2019, at Network Neurology, which is unfortunately not around anymore, was a victim of the pandemic, we ran a small pilot study looking at people using the Neurocycle and how that happens over time. We recruited from the local community, and we were able to run a nice little control study here, but very much exploratory. We're looking to see what is changing over time, how that impacts, and we're built a very large team to try to bring in as many different expertises as we can. So in thinking about that, there's a whole bunch of people to thank. This is a short list of the big ones: Renee Paulson, Nick Kapushian, Gabby Lynch, Alexandria Leaf. All these people had a huge impact on our ability to do this work and then interpret the data afterwards. And you can see from a wide range of groups, so thank you to them. The first paper that we ended up putting out here came out about a little over a year ago now, looking specifically at correlates of beta activity, and we're going to talk about that data today. But then also, much more recently, literally I think this came out 4 days ago, this paper is finally out, and we're going to talk about some of that data as well. The goal today is basically just to introduce you guys to the study and sort of this psychoneurobiological approach, where instead of just asking a simple question and trying to just do a hypothesis of that one thing, this is a slightly different approach of saying we want to look at how people go through this healing process, and we're going to use as many research tools as we have to try to analyze how they're changing over time.
So we moved into a period of doing research that was very pretty unusual because we looked at so many different factors. So psychoneurobiology, mind, brain, body, and we looked at, in terms of the psychological stuff, we looked at narrative, we looked at various different measures. We're going to talk about a few of those. We looked at, obviously, the used QEEG, we looked at the neurophysiology, we looked at various biomarkers, and the whole idea was to be able to compare a person to themselves, as well as obviously looking at large data sets. And the whole idea is to be able to show that there is this healing journey. A large focus of our work has also been to look at habit formation. Someone who doesn't just experience a change over a short period of time, but to actually carry that over into creating useful memory that will be able to help them to make the changes that they need to make in their life. And this is a big problem, carryover, not creating sustainable change, falling back, getting stuck, etc. These are huge aspects to mental health that are problematic and have become progressively more problematic with the very biomedical approach that has been taken in the last 40 years. So the approach that I've been working on for the last literally 40 years, back initially starting in South Africa, has been to look at the whole person and this psychoneurobiological approach, of which we're going to show you elements today. So just to go back a little bit in time, do you want to do the overview of the first study, and then we'll...
Yeah, so in finally analyzing this data, which if you saw the timeline at the very beginning, we collected all of this in 2018, 2019. Then we got interrupted a little bit. So we ended up finishing up analysis on this about 2 years after the fact. So first set of data we ended up putting together is looking primarily at chronic stress and anxiety, which is a very common theme that we see. And looking at that in the context of beta activity in EEG. We'll talk more specifically about EEG in the analysis later. And we also assessed a set of psychometric data, including pre-existing questionnaires that are well established in our field, and then also a new sort of composite questionnaire that we are trying to create to have one thing that we can give people as opposed to asking them to complete 40 minutes worth of paper tests. And then we also did blood serum homocysteine levels. So in this first paper, we were really looking to see the efficacy of the Neurocycle in regards to stress and anxiety. In the second paper, which just came out, we look in the same sort of pattern. So we're looking at psychometrics, EEG, and blood serum levels, really more keying in on habit formation. The process of, if I'm going to try to change something about what I do on a day-to-day basis, first of all, can we do that? Yes. How long does it take? And what does that trajectory, that journey of creating that long-standing change actually look like? So the tool that we're using in terms of the intervention here is called the Neurocycle. I'm going to let Dr. Leaf talk a little bit about the Neurocycle.
So this journey of the Neurocycle began many years ago back in South Africa, where I was actually in a lecture, a neuroscience lecture, and in the early 80s when we were told the brain couldn't change, and we were having this lecture, and are we changed as humans? We know that we're different all the time. And I remember asking the professor, but if we are constantly changing, the brain has got to be able to be changed as well, because we, as with our minds, are experiencing life, and that's changing, therefore the brain's got to change. And I say that to say the going philosophy back in the 80s, from about the 50s to the mid-90s almost, was that once your brain's damaged, that's it. Now we know that that's not the truth. Now it may even sound crazy saying that in a place like this, but that was the reality. And so the professor said, go do research. And I said, okay, what field? And traumatic brain injury was where I started. The reason being was that there was such a dearth of research in traumatic brain injury at that point. And what I did was develop a system, develop a theory, fast forward all these years, and I did some of the earliest neuroplasticity research, as Julie mentioned, back in the late 80s, showing that when you direct how your mind input, what you are thinking about, how you are thinking, you can change the brain and the body, because the mind is driving our mental and neurophysiological aspects. So if you did, your brain and your body disintegrate. When you're alive, it's your mind that's your sentience, it's your mind that is driving both mental and physical functions. So for example, right now, you're making somewhere between 800,000 and 1 million cells every second. Your heart's beating, your blood's flowing, your brain is responding. All of this is going to happen if you're alive. So a huge part of understanding mind and mind-brain is understanding that this aliveness, this mind aspect, is something that's us, and how can we direct that? And in doing that, I did a lot of deeper research looking into the conscious mind, the subconscious, the non-conscious, the unconscious, what the difference is, how does that work? And I was trying to find and understand, how does life, like this lecture, get inside your network? How is what I am saying and what Charlie's saying and what you're seeing, how is this becoming part of your mind-brain-body connection, and how is this information going to influence and drive use? In other words, how does life get into you? And if it's good stuff, how do you enhance that? And if it's bad stuff, like a toxic experience, can you reverse engineer that? So I was trying to understand that process in my research. So this theory developed out of that, called the Geodesic information processing theory, which pretty much looks at the idea of the non-conscious driving the conscious mind, driving our output. So that's the green is the non-conscious, purple being the conscious, and then the blue being the output, the pink down the bottom being just very simple explanation. There's a lot more involved, obviously, showing that there's the change in the brain and the body in response. So our brain and our body aren't self-generating. Your genes aren't self-generative. They have to be activated. So your mind is your activator. So we're consciously awake now, hopefully, and our conscious mind is awake when we're awake, and it's functioning, and it functions quite slowly compared to the non-conscious, N-O-N. The non-conscious is not the unconscious. The non-conscious is not the subconscious. They're different. The conscious mind is how we are consciously aware, as we know, and we can focus on limited things at a time pretty fast, but it's kind of this speed. And then you've got your subconscious, which is like a waiting room. It's like a doorway, or a portal, or a waiting room is an even better analogy, where what's prominent in your life is waiting to be dealt with. Your non-conscious is the biggest part of you. It's infinite. It is beyond present, past, and future. It's where every experience that you've ever had since a certain point in your development and all the way through to the age that you're at now is stored. And it is when you talk about life becoming stored in our networks, we talk about this experience. I'm speaking, you're hearing words, but it's auditory sound waves, these electromagnetic light waves, this all gets captured. So when we talk about mind, we can actually, to a certain extent, measure what mind is, biofield, etc., using various different forms of classical and quantum physics. But this experience is initially this electromagnetic field and quantum fields, gravitational fields that we take in, and we put that into the brain and the body simultaneously. And this creates the changes in the brain, which is neuroplasticity. It creates changes in the body, which is plasticity. So every experience is building into every cell, and we have around 37 to 100 trillion cells in our brain and our body collectively. So everything you're hearing now now, sorry about to tell you this, but you have 37 to 100 trillion versions of me and Charlie in you growing at the moment. Okay, so in every cell, and it's different, obviously collectively together. So in the brain, it looks like a tree. We know what neurons look like. We see from the research that I've been involved in, we don't believe that memory is stored in the synaptic connection. It just doesn't retain memory long enough. It's more in the dendrites and going into the microtubules, and we don't have too much time to go into that today, but that's part of the work that I've been doing, looking at how memory is actually stored within thought networks. And then that process of getting in and getting out. So the neurocycle, the research birthed the theory, birthed the neurocycle. I worked with not just traumatic brain injury, but dementia, stroke, severe emotional trauma, learning disabilities. Then I saw this working for my patients. I thought, I want to do this, and started using the process for self-enhancement and whatever, fixing up. We all are messy. Let's admit, we all messy. We all got a mental mess, and this is something that we all need to be dealing with all the time. So it basically boiled down to mind management. So I needed something for my patients that were so severely constrained from a traumatic brain injury or dementia or a trauma or battling with learning, that wasn't this huge science thing. I had to take the science and make it accessible, and that's what the Neurocycle is. It's taking this process of how stuff gets in and into our mind, and identifying what's driving us through signals that our emotions, behaviors, our bodily sensations, and our perspectives, finding the thought, which is a cluster of memories, the data that's attached to, and then basically either reconstructing if it's something that's toxic or building a new habit into the brain. So that's a basically simplified, complex process, simplified into a 5-step process. And if we look at the slide over here, we've got and this is years, obviously this is over 40 years, so it's developed. We keep doing research. We've done lots of different research in different environments. And with different patients, populations. So essentially, probably the easiest way is just to look down here. First, there's 5 basic steps, so simple when you look at them. Equivalent, a good analogy is flying a plane. So if you think of it, you prepare a plane. Before a plane takes off, there's the engineer, there's they check all kinds of things in a certain part of the airport, then the plane is taken to where it's going to load the passengers, there's more checkups. So there's preparation. There's a very general preparation that happens. Then the pilots take off, and then they fly, and then they land. The Neurocycle is that kind of cycle. The preparation is the equivalent of things that we're very familiar with, things like breathing and meditation and visualization, and you need decompression, thinking of 5 things you can see and 4 things you can touch, that sort of thing. And that creates general awareness, calms down your neurophysiology, does a whole bunch of stuff that there's a lot of research on. But what research shows is if you just create general awareness, you bring things up. And there's a lot of research coming out currently showing that if you just have general awareness, you're going to crash. It's not enough. So you bring things up. Now what do I do with what I have brought up? So it's kind of like the equivalent of the airplane analogy is I can meditate, I can breathe, and it's going to bring things up. But if I don't do anything more, I'm never going to take off. I'm just going to get stuck and very frustrated with frustrated customers who aren't flying anyway. And if I do happen to take off, but I don't actually do something about now what I'm becoming very focused on, because general awareness, the preparation of the plane, makes you aware of a lot of stuff. Focused awareness when you take off is, okay, I'm focusing very specifically on how am I feeling, what am I doing, how am I showing up, and all these things. If I just stop there, you're going to crash. If a pilot only knows how to take off and can't fly and land, you're going to crash. So we have to go beyond that. We have to fly the plane, which has 3 processes to it. So the first step of gather awareness involves the general preparation of the plane, just to give you the analogy, and the taking off. And it's very specific, general awareness to focused specific awareness. And then you fly the plane, which is reflection, thinking of reflection like a light through a prism. If you shine a white light through a prism, it will come out as a rainbow on the other side. So for every thing that we focus on, there's a whole lot behind it. So you start reflecting, which is a process that starts taking you into the depths of your unconscious. So one of the things that the Neurocycle is doing one of the many things, is that it is helping to get our conscious mind connecting with what's in the waiting room of the subconscious, which has been sent there by the non-conscious, because our non-conscious mind is operating on a wired for love philosophy, which essentially means that nothing in our mind-brain-body connection is against us, it's for us. So we are for survival, etc., etc. So everything about our neurophysiology and mind, etc., psychoneurobiology, is to help you survive. So your non-conscious is searching for the habits, the experiences, the traumas, these things that are blocking us from growing, or things that are great that we're not focusing on sufficiently. And it puts those in the waiting room, and as we are ready, we get signals. So something like feeling depressed, feeling that life sucks, having gut issues, withdrawing. That's 4 signals. That doesn't mean you have a mental disease and a broken brain. It means that there's a because of. You're showing up in a certain way because of. So by taking the time to focus on what the signals are coming from the thought, with its cluster of memories down to the root. If you think of the analogy of a tree, there's a source, there's a root, you can then start reconstruction. You can never change what's happened to you. You can never take the abuse away, take that experience away, but you can change what it looks like in your network, so therefore changes how you play it into the future. So the Neurocycle is doing that kind of work. Just very quickly, I've spoken about the non-conscious, subconscious, and conscious. Unconscious, what's that? It's a brain state. So it's when you're asleep, or when you are under anesthesia, or hopefully not knocked out by something like a baseball bat, but it's when you have that shift. And it's people, when they are unconscious, they are still processing what's going on around them. So that is different too, and it's used incorrectly. People talk about the subconscious and the unconscious as the same thing. They're not, they're different. The subconscious is a portal, it holds nothing, it's like a waiting room. And then you've got the non-conscious. So the Neurocycle is based on that understanding of the different levels and streams of consciousness and how things go in and out. And it's got 2 phases. So linked in with this is, if I'm going to create any kind of change in my life, or help a client or a patient or whatever, or help you, we have to it takes time. We all get it when you go and have a surgery, it's going to take time to heal. We all get it when you go and learn to play a sport or a musical instrument, but when it takes time. When it comes to the mind, we live in a current 40-year-old, 50-year-old philosophy of a pill for every ill. If you feel uncomfortable or depressed or anxious, there's something wrong with you, there's something wrong with your brain, it's a symptom of a disease, and that's the biomedical model, which is very brilliant for the physical brain and body, but it's not very good for mental health at all, and has been disproved by top neuroscientists. So we can't talk about that depression as being a chemical imbalance or a problem in the genes, which is also just not accurate science at all. We need to talk about that depression as a informational signal connected to your behaviors, your bodily sensations, your perspective, all coming from a thought that has a source, and we need to do the work of reconstruction. And that takes time. And that's habit formation. So habit formation is finding the bad stuff, deconstructing and reconstructing and stabilizing. And it's also, if you want to build a new way of functioning into your life, like build the sorts of things that they teach here in the Brain Center, build those excellent habits into your life. So habit formation doesn't take 21 days, as I'm sure you're all familiar with. It comes from some anecdotal research from a Dr. Meltz back in the 60s, who was a surgeon, and he discovered that, like we do know, accurate stem cells heal in groups of 21 days. So physically we heal in these groups of sort of more or less 3-week blocks. And he anecdotally was pretty accurate in saying that there's change happening mentally too, which is true, because our mind's driving the brain and the body. The mind is a priori, driving brain and body. But that became a myth, like a lot of things do. And if you really look at it, there's a lot happening in the first 21 days, a massive amount of stuff, and it's very learning directed. And Charlie's going to take over now and show you in a moment, and show you just what's going on in terms of gamma, beta, different frequency bands and so on, and biomarkers and so on. But then once you reach that point where there's like a lot of work, and things get worse before they get better, which we call the treatment effect. I mean, when you start facing a trauma or dealing with those anxious thoughts, or start really looking at, why am I showing up like this in my relationship? It hurts, it's hard, and there's a lot of ups and downs. And then you get to the point where you've done a learning, where you've built this new, healed the roots of the tree, and you can never rip the tree out, unfortunately. Once something's happened to you, it's there forever, but you can change what it looks like, by meaning I can go to the root system, I can clean up the root system, and I can grow a new tree, and no longer is it all ugly. The majority is this beautiful tree with the little branch that's the memory cluster from what happened. And that hard work takes around 3 weeks, and then the balance of the 42 days, another 6 weeks, so another 2 cycles of 21 is where you stabilize. So you move into what we call automaticity. And automaticity is not automatic, robotic, dumb stuff. It's highly intelligent. Habit formation has unfortunately been very linked to sort of robotic type things. And so when you talk about the unconscious or things becoming automatic, it's like you're being driven by a machine or a program that there's no intelligence to it. Far from it. That is so absolutely inaccurate scientifically, and if you think of it logically as a human. So when you learn to drive, take that example. When you learn to drive, you're so consciously aware initially of everything. You reach a point where you can drive. It doesn't mean that you're not thinking. It means that you've automatized a very intelligent network that changes every time you get in the car, and more information is added because your brain is always changing, because your mind is always changing, and every driving experience is adding to that. So we are constantly in a state of change. And the philosophy, therefore, of the second part is that when we automatization is a very intelligent turning of this new way of functioning into something that is useful memory, that I can be triggered in a situation, that I can revert back to this new way of functioning, the big green part of the tree. And to get the big green part bigger than the little toxic branch, if you can visualize that, that takes time. So if you stop at day 21, which I call the danger zone, or we call the danger zone in our research, there is a good chance within a week that you're going to start dipping. Because you think of that new forest analogy, this new way of functioning is a little tree. It's beautiful, it's new, it's got the green part, it's healed roots, etc., but it's little. And you have trillions of other trees, which are your experiences. And just it looks like trees in the brain, but the thoughts look like hedges in the microtubules of your cells. So we know that memory is in every cell as well, as I mentioned. So essentially, it's tiny. So you have to add active energy to grow it. So, watering the plant, whatever, all those great analogies. But essentially what you're doing is you are driving energy towards each of those, towards that thought, which is made of memories, because memories are the data of the thought, and making it bigger and bigger and bigger. Only when it has sufficient active energy, in other words, it's big enough in the cluster of forest that it's big enough it's not this small with everything around it, it's as big as the others, can I then draw on that as useful memory? And that's automaticity. So the Neurocycle is a planned and guided process that you do daily for around 15 to 30 minutes for the first 21 days, and thereafter for about 5 to 10 minutes for the balance of 42 days. And one last thing, if you've got a major trauma, like I've had patients who've had extreme traumatic abuse, physical abuse, sexual abuse for maybe years of their life, and they've taken up to 2 years of neurocycling to move forward. Each neurocycle, each 63 days you will move forward, but you're not going to heal that level of trauma in one cycle. And that's why we often see complex trauma is going to be around about 254 cycles, or maybe 700 days, sorry, not cycles, days, or 700 days. So one of my patients is popping into my mind, it was a full 2 years before we started getting to the point where that patient was able to see all the different impacts in their life. But each neurocycle was progress forward. And the beauty of the neurocycle is, I say a patient of mine for 2 years, they were independent very quickly. So I would put my patients through a 9-week cycle, and then after that it would be monthly and petering out. We have to empower ourselves and our patients to be able to, and our clients and our children, to be able to help ourselves. We've got to create an internal locus of control. And a lot of the current therapeutic and psychiatric interventions are an external locus of control, not following the healing journey. Last thing about the healing journey, which is really impactful, is that around day 32 to 38, you get incredible insight. And there's a lot of grief that can come with that. When you see all those years maybe that you lost from the trauma, or all that kind of experience, it's sad, but it's a wisdom insight. It is, that's what happened. What can I do about this going forward? But if you stop at that point, there's a massive dip in your your entire signal focus, so in other words, your behaviors, your emotions, etc., that dips from day 32 through around about day 38. And if you stop there and if you don't know that that's going to happen, you can feel really awful. And this is very often where people fall off in therapy. If they haven't fallen off at day 21, they stop too soon. There's various different danger points along the way. So what we are showing in our work is that you need to follow the healing journey. And the healing journey has ups and downs. And if you prepare someone that around about that time this could happen, when it does happen, you're going to cry, you're going to feel depressed, but you're going to have the anxiety, and that's okay, because those are not bad things. There is no bad emotion. You're never going to get rid of a panic attack, but you're going to learn to manage it. This is part of taking that energy where it's controlling you to you then directing the control. I'm going to hand over to Charlie to give us all the gamma, beta, technical stuff behind what I've just said.
So here, this is just sort of the outline of the Neurocycle. If people are interested in sort of seeing what this looks like for themselves, you can find our app on the App Store, both Android and Google, Android and Apple. So feel free to take a look for yourselves. Jumping back now into the pilot study. So we looked at QEEG, which is quantitative electroencephalography. Give you a bit of a background, a couple of terms we're going to be using. Different frequencies of EEG activity have different names. They're after Greek letters, so beta activity is typically defined as between 13 and 30 hertz. It's also associated with stress and anxiety, specifically when it's a very high amount of beta activity. Very common to talk about in EEG is this kind of a balancing act or a Goldilocks zone. There's no one EEG frequency that is good or bad. There's always a certain amount of activity that is appropriate for any given activity that you're trying to do, any situation. When you're sitting here in a lecture trying to pay attention and not fall asleep, we want a good amount of beta activity. We want to be able to think. But when you're sitting at home trying to get to bed and relax, a whole bunch of beta activity is going to show up as rumination, and now that's not really serving your purpose of trying to fall asleep. So it's always a matter of what is the appropriate balance of different brain activity for whatever I'm trying to do at the moment. So whenever you hear me talking about beta and anxiety, that's when we have too much beta. There's always a good amount. There's too much or too little, so it's that Goldilocks situation. So, as I said, beta amplitudes, when they're heightened, are correlated with anxiety, and they can also be observed in different manifestations of things like PTSD, bipolar disorder, schizophrenia, and addiction. Gamma is a higher frequency range. Ranges basically from 30 hertz up. You'll see some people report upper end of 100 hertz or 120 hertz. As EEG equipment gets better, that gamma range keeps getting expanded upwards and upwards. So it's the high one. It's the one that's at the top, right? It's shown to be involved with learning, memory function, recalling of information. It seems to increase during the learning of a behavior, and then once that behavior is learned, it seems to fall off. So if we think back to what Dr. Leaf was just saying about the idea of learning a new habit and then having that process of optimization, you'll see an increase in gamma as we're acquiring and learning that skill. And as we start being able to automatize that process, we should see gamma falling off a little bit. All right? A small side tangent. There's a very long-standing lack of consistency in the EEG research world. Primarily, this has to do with poor reporting of exactly how people are doing their statistics. So in this case, when we think of frequency bands in EEG, it's important to know that it's a continuous range, but they can't overlap. So you can't say beta starts at 13 hertz, goes to 30, and then 30 hertz is also gamma. There has to be some point where they cut off. So a lot of the research that is not replicated around in our field, if you go and look specifically at methodology, there's a long pattern of not actually doing the same analysis. And so it becomes very difficult when you look at things like meta-analyses to actually draw true equivalencies. So just for those of us who aren't as much in the EEG world, there's a long-standing issue there in terms of reporting specific analyses. Big push for open science and open analysis pipelines is important. So there's a big search for that consistency. There's some direct contradictions. So for instance, Diaz in 2019 saw that low beta was associated with quiet and introspective thinking, which they then thought this might be sort of a healthy range of beta. But then later, amongst people with tinnitus-related distress, they saw an increase in that associated with their distress. If you go and look at these papers, they're actually computing their beta bandwidths completely differently, even though it's on the same frequency range. So there's a big issue in replicability here. It does seem that it comes down to specifics of analysis. So this brings us to the need for an approach that encompasses more than just one measurement type. So in 2002, the World Health Organization reported that there's a 13% increase in mental health conditions and substance abuse disorders from 2019. That's huge. That means that if you're in this room, I think we've got, what, about 60, 70 people or so? About 7 or 8 of us would have acquired some kind of mental health issue during that period. That's significant. In 2019, that same year, Newson, and I'm going to not try to pronounce his name because I don't want to mess it up that badly, called for research to contribute to the creation of this large QEEG-style database that could be assessed to inform people and standardize that assessment. This actually has been done in South Korea. They had a foundation that basically took government funding and said, okay, let's gather up every single EEG recording that's been done in any hospital in the country over the last 10 years and create a normative data set and use it to look at things like mild cognitive impairment and Alzheimer's and so on. And they were very successful. The challenge is now that that is all people from that one country, and how well does that generalize globally? All right? But all of this to say that we have the technology to do this, but we need to expand beyond just one modality. So in our current study, we did a double-blind controlled study, so I was the only person who knew who was getting the Neurocycle and who wasn't. So over the course of 63 days, we brought people into network neurology, that neurology practice in Charleston, and half of the group ended up getting the app, half didn't. And they came back on days 1, 21, and 63. At each of those time points, they had a QEEG done, they had blood work drawn, and they had a set of psychometric questionnaires that they did. In addition to that, the people who had the Neurocycle were working through that every day on the app as well. So we ended up at the end of the study with fewer people than we started. Obviously, we're asking people to complete for a long time. So this really is a pilot study. We've got about 11 people. But importantly, what we're doing here is we're comparing somebody to themselves. There's so much interpersonal variability, especially in brain measures, especially in psychometric data, that doing a within subject style design where we're comparing somebody to themselves over time gives us a bit more observational power than just trying to say, does the control group look different than the treatment group? Because the assumption that they're the same at baseline is a silly one, all right? So on a pre-screening day, we had them do inventories for clinical anxiety and depression. These are the HADS A and HADS D. These are pre-existing questionnaires that are very well established in our field. And then on days 0, 7, 14, 21, 42, and 63, they did a whole series of psychometric tests. So they did a BBC well-being scale, which covers several different subscales. They did the HADS A and D again. They did the PHQ-9, which is a patient health questionnaire that's used pretty commonly in hospital systems. And then they also did what we call the Leaf Mind Management Questionnaire, which is a questionnaire Dr. Leaf has worked on for many years now to try to find a good, relatively short way to evaluate a bunch of these different subscales, because as we all know in research, getting somebody to sit down and do 40 minutes of questionnaires can be a bit of a large ask for people. And then additionally, on days 0, 21, and 63, they got the blood work and the QEEG. We then also gave them a 3-month follow-up where we had them do those well-being scales again 3 months after. And to my amazingly surprise and shock, we had 100% retention for that 3-month follow-up. So we've got all 11 people for this whole time period. All right. The Leaf Mind Management Scale is specifically looking at how we're progressing through the Neurocycle. Not out yet, but we did have an acceptance for the validation study for that scale. It's in review now? Yep.
Yeah.
So if people are interested in looking at that scale or potentially integrating it into their work, please get in touch with us. We'd be happy to help you work with that. And what we did to sort of verify that this is a good scale is we compare it to a bunch of other existing measurements. So I'm going to hand back to Dr. Leaf to talk about that.
So I'm going to read it from here. So basically, you're going to move it forward, right? Maybe. Yeah, okay. So essentially, the Leaf Mind Management Scale is these are different through the middle. Those are the different scales, the different categories, and then those are the questions out of each category. If we go to the previous slide very quickly, Charlie, it's looking at their ability to self-regulate through the Neurocycle. So as Charlie said, there's a lot of history to this thing. We've done a whole validation study over many years and so on, very complex study. And I think let's jump straight to that comparison. It's the easiest thing to see over here, okay? So what we did was there's research showing, and Shapiro is the leader in this, showing that we need to be able to make sure that if we're going to help someone, we can measure in the moment, like you can do mindfulness training and you will see changes in cortisol and in behavioral stuff and so on. But that's what we call a state change. But did that transitioned to the long term? Did they build an internal locus of management, mind management internally, that they then carried it over into a trait? In other words, it became an automatized habit. They could draw on it, they could use that in their life. Now, if you want to change something, you can't use it in your life, well, what is the point? So we wanted to get a scale that fulfilled the criteria to be able to measure that, as Charlie said, in a very efficient and effective way that people could self-administer as well. So it's built into our app. It turns up, it's at day 1, 21, 42, and 63, and essentially Shapiro is the leader who spoke about there's certain factors that we need to have in place in order for a person to transition something from state, which is in the moment improvement, to long-term improvement, in other words, trait change. And so we then compared our scale in the process of all the validation and so on to the top 15 most cited scales that are cited and used in this field. So what you see in this particular slide over here is a comparison of our scale to these other ones. And if we can maybe just flip back to the other one, there we go. Charlie explains it better than I do.
So the idea here is that Shapiro identifies all of these neurological mechanisms that are involved in mind management, so this attention control, self-awareness, emotional regulation, self-regulation, and he defined those as these different factors. So he says the factor of flexibility, of values clarification, exposure, and self-regulation. So when we go ahead and compare the Leaf Mind Management Scale to all of these other ones, we say, okay, do we successfully address and measure these different factors? And the Leaf Mind Management Scale manages to hit all of them, manages to do that without asking them to do more than 15 minutes or so. So we're trying to keep it as short and sweet as we can without sacrificing too much on the actual richness of the data that we get.
And what was really fascinating with this, and you're going to see more about the biomarker component now for the big study, was that we saw when in the validation study, we did a two-part study. We also looked at the changes. Was there any change, for example, in the DHEA cortisol ratio, which is really important in terms of, there's a lot of established research that the DHEA cortisol ratio is very strongly linked to how people are managing their stress, and things like homocysteine and so on, which we'll tell you a bit more about now. So we also looked at so we confirmed the validation in simple language using also the biomarkers, and just to see, and as we compared them, we saw that there was changes and shifts in the biomarkers as the LMM scores improved. So we saw changes in these biomarkers, which was a shot in the dark. We didn't know if a validation scale would have that level of impact on our biology, but it did, which was very interesting to confirm. So now,
So to give a bit of background, because it certainly was not in my wheelhouse when we started doing this research, give a little bit of background to some of the blood measures that we're going to talk about. So homocysteine, and all of our blood measures, basically we hired a licensed phlebotomist to come on site and collect a bunch of blood samples, and we sent them off to a private lab to do an analysis for us and send us back the data. This was definitely outside the realm of the kind of research that we had done before, but surprisingly easy to get set up and do, as long as you don't try to do it yourself. Bring in somebody who knows what they're doing. It's about the team, all right? So they come in and they took blood levels. Homocysteine has these sort of normalized ranges of if you have less than 15 units, it's considered normal, 15 to 30 is moderate, and so on. Similarly, and in terms of what that means, homocysteine is an amino acid. It's normally broken down by things like folate, vitamin B, B12, and creates other needed chemicals for the body. So what homocysteine is broken down into is stuff that we need. It's been shown to be significantly elevated by stress. So too much homocysteine can be associated with things like damage to the artery linings, blood clots, blood vessel blockages, heart attacks. Not good stuff, right? So generally speaking, we want homocysteine to be lower, but we do need some of it in our body. So again, it's a Goldilocks principle of too much is bad, not enough is bad. There's a certain amount that's right for any given person, but that might not be the same person to person, right?
By individuality.
Yeah. Prolactin is a neuropeptide that promotes physiological responses mostly related to reproduction. So most of us are used to hearing about prolactin mostly just in women and females. Men have prolactin too, and it is also still a useful measurement to look at in men. So when we see unmanaged stress, we can see prolactin levels either shoot up really, really high or down very, very low. So we also measured prolactin levels. And shout out to the University of California, had a wonderful article about telomeres, I think it was about a year ago, and I'm lovingly borrowing their beautiful little GIF images here. Telomeres are the protective casing at the end of DNA strands. Each time a cell divides, some of its telomeres and an enzyme called telomerase can replenish those little end caps. However, under lots of unmanaged stress, that supply of telomerase decreases. So what happens is we see people who are under long-term chronic stress, the length of their telomeres, those little caps, becomes very short. So you can think of this as a more slow-moving gauge of parasympathetic versus sympathetic tone in an individual. This is newer science, so we actually called several different people who are more informed in telomeres to help us with this, but it ended up being really interesting data, so we're very happy.
And one of the very interesting things is that generally telomere work has been done on like nutritional changes and dietary changes, and the thinking behind telomeres is that it takes up to 5 years for changes to be observed. But then there was some new research by Lisa Epel, who you may have heard of, and Elizabeth Blackthorne, who won the Nobel Prize on telomerase, and they started saying, hey, maybe a bit of mindfulness can change telomeres. So based on that, we decided, okay, well, let's see what we see. Let's see, it looks like you can actually see changes in telomeres in a 9-week period, and it looks like mind plays a massive role, not just diet and exercise. And so that's why we incorporated this in the study, and we're very pleasantly surprised to see very healthy changes in telomeres in periods as short as 9 weeks.
Yeah. In addition, so that's all of the blood work. In terms of QEEG, this is EEG data collection. We use the 19-channel EEG cap. This system that we used is a clinical system, so we did this at a neurology practice. So this isn't sort of your research style thing where you can have a very, very high sampling rate. The idea here is the recording that we did could be done in any neurology practice with their existing equipment. So we didn't want to try to do something fancy that wouldn't be implementable later in a clinical setting. So this is a resting state recording. We did 10 minutes eyes open, 10 minutes eyes closed. All they're asked to do is sit in a comfortable chair in a dimly lit room and not fall asleep on us. All right? That can be a bit of an ask sometimes. All right? Sampled at 256 hertz for the EEG nerds in the room, link mastoids references. And again, important to me, none of the people collecting this data knew whether or not the person was in the group or not. So they're not having a conversation about, oh, how are you doing with the app? None of that, all right? To analyze the QEEG data, one thing that is important in EEG is it's a very sensitive measure, but unfortunately that means it's also very sensitive to things that aren't brain activity. So movement, muscle activity, all of these kinds of things can, what we would call, dirty up your EEG data. So things that are recorded that aren't actually brain activity. For many, many years, the way it has been dealt with in clinical settings is they literally just cut it out, chop out that time, and remove it from the trace. One of the issues when you do that is if at the end of the day I want to be able to compare person to person, but this person's recording is 10 minutes long and this person's recording is 7 minutes long, now we've got statistical power problems and all of this. So what we did here is use some work out of Dr. Dunham's lab. At the time, she was at Harvard finishing her PhD. Now she's running her own lab, the Pine Lab at Northeastern. Shout out to her. And she works primarily with pediatric EEG, so little kiddos who like to move around and squirm and do all kinds of things that aren't terribly conducive to EEG studies. So her and a bunch of really smart people that she works with who are good math folks went in and created what's called HAPPY. We all love good acronyms. This is the Harvard Automated Pre-Processing Pipeline for Electroencephalography. And it should make you happy because you no longer have to do manual artifacting. But basically it's a MATLAB script that goes through and uses a set of algorithmic cleaning processes to do independent components analysis and wavelet analysis to try to remove artifact-based things from the data. Nicely, it does this without any input from the researcher, so it's an algorithmic cleaning process that is identical for every single person, leaves you with the same amount of time for every single person, and gives you the ability to do direct comparisons without having to worry as much about contamination of our signals. All right, I already talked about that. So let's start looking at some actual data. This is just the toxic stress subscale over time from the leaf mind management scale. The orange here is the treatment group, the folks who had the app. The blue is the people who are in the control. As you can see, importantly, as we were talking about measuring compared to themselves, they're not the same on day one. We shouldn't expect everybody to be the same on day one. So it's important that whenever we do our statistics and our analyses, we're always going to be comparing relative to baseline. All right? But we can see in the treatment group, we do see a drop in our anxiety scores over time. It bumps back up on day 21, just like Dr. Leaf was talking about, because what we're doing is we're making them aware and asking them to think about all of the problems and challenges they're dealing with. That's inherently going to increase your stress, as the sort of the analogy of surgery. You have to cut somebody before you can help them. All right? And interestingly enough, that even at 3-month follow-up, they're continuing that same trajectory of lowering a little bit. All right. Importantly, this was significantly correlated with the HADS-A anxiety scale and the HADS-D depression scale as well. So we can see that we're getting at some of those same factors with the LMM. In terms of awareness here, on the left is our control group, on the right is treatment group. The 3 columns in each are the baseline, day 21, day 63. Our control group did a wonderful job of not changing for us. All right, and our treatment group starts about the same and increases over time. The change from day 1 to 21 and 21 to 63 are both significant changes, and at day 63 they now have a significantly higher awareness score than their control counterparts. All right.
And the kind of awareness that you're looking at here is not general awareness, it's general awareness plus focused awareness, so it's an awareness of an insightful type of awareness.
Yeah. So generally speaking, we're going to look at beta. In this context, we're thinking about too much beta being indicative of anxiety. So here's the change from baseline. Again, blue here is the control group, orange is the treatment group, the gray is the average of those two. What you're seeing here is change relative to baseline. So if they didn't change at all, the bar would be completely flat with the x-axis. You can see here from day 0 to 21, beta increased in everybody. In fact, it increased even more in our treatment group, the people who are actively being asked to take awareness of these problems that they're dealing with. Then, from day 21 to day 63, it drops down.
So we saw consistently, and you're going to see this coming up now with the graphs, we saw a pivot point at day 21. So this thing of learning is happening up to day 21, lots of challenging learning, lots of changes, things getting worse. In fact, the telomeres got shorter for the treatment and control during that time period, but then they lengthened and didn't lengthen in the control group. So we see a pivot point coming up with the gamma, the beta, all the different measures in terms of all 3 psychoneurobiological measures. We kept seeing this same pattern of the climb and then the pivot point at 21 and the automatization happening across all these different measures.
Sort of the sum up of findings from that first paper is we did see a change in the toxic stress subscale scores and the homocysteine levels from day 1 to day 63. Those are significantly predictive of the change in low beta power. So those 3 things together. And the R-squared value of that is 41.4. Just those 2 things account for like 40% of the variance in the brain activity. Homocysteine was also a very strong predictor of the beta coefficient, not significant, but with a beta of 0.613, so it's approaching, again, very small population here we're looking at. So we're looking at trends in addition to significances. All right, and the toxic stress subscale, the change was meaningful in its contribution with a beta coefficient of 0.39. This is those numbers if you want to look at them later. Gamma is about, here we're talking about habit formation and automaticity. Remember that literature of that. It's increasing while we're learning, and then once we sort of internalize that, it drops down again. So that's a copy slide. No, it isn't. Okay. From day 1 to day 63, toxic stress scores are inversely correlated with gamma. All right? After we looked at that, we also, this is the prolactin data, the change in prolactin over the course of the entire study was a significant predictor and accounts for 65% of the variance in frontal lobe gamma power. So there's something going on between prolactin and gamma activity. We can't really say too much about it yet, but this is worth following up on. All right, another wonderful example of why measurements within subjects are important. On the left here, this is telomere length data. The black line at the very top there is the treatment group, and the gray line at the bottom is the control group. They don't start out similar at all. On the right is comparing relative change compared to baseline. So, at the beginning, telomeres drop in length for both groups over 3 weeks. So this is already interesting because originally we thought telomeres changing, we're talking about really, really long time scales. This is a change within 21 days. So maybe this is something that we can measure on a more finer time scale to look at information. But interestingly enough, when you go from days 21 to 63, that control group keeps shortening. It just keeps getting shorter. The treatment group reverses that direction and not only increases, but ends up higher than they started. So at day 1, they're here, it goes down as they're made aware, and they rebound and end up actually overshooting where they were originally.
So the telomeres got longer in 9 weeks.
This is looking at frontal gamma power, again, related to autonomy. So this is one of the LMM subscales. We were talking about this earlier, the idea of correlations having different directionality at different time scales. So in a short time period from baseline to 21 or 21 to 63, they're inversely correlated. You see those lines crossing each other. But when you measure longer periods over time, they're directly correlated. So in the short time span, these two factors are interacting, but you still, over the long period, need one in order to have the other. So there's a more complex interaction going on here. This was one of the findings that we said, okay, maybe we need to be doing this for more than just the 163-day cycle to really understand what's going on in this entire picture. So one of the things we're planning on doing later is following people out longer than one cycle to see this journey in a little bit more detail.
And then you'll see the pivot point as well at day 21. So as autonomy actually decreased, the black line, they felt less autonomy, less control, and then it improved at day 21. So as they were sorting everything out and learning, it got worse, but the gamma increased. So there's a lot of work going on. So that's why we're seeing that that relationship crossing over, and then all the way through every measure, we kept seeing this pivot point, this shift at around day 21.
Yeah. One of the last sets of graph data. So again, this is just looking at the low gamma between groups now. So black lines here are treatment, gray line is control. You can see during the first 21 days, everybody is increasing. We're making them aware of things. They're becoming more mindful about it. The change from day 21 to day 63, the treatment group has a much larger, significant drop in comparison.
Which is what you want. It means automatization is happening. You don't want to be consciously and deliberately like this all the time. You have to get to a point where you can live and use what you've learned to help you cope.
Yeah, so you've got this learning phase and an optimization phase. So just to sort of, just wrapping up here. So this was a summation of all the things in that first beta paper. So this idea of improved neurophysiological functioning, and we see that in terms of a decrease in beta over the second phase of the study. We see an improved psychological functioning, the decrease in the toxic stress subscale, and we see the improvement in the biological functioning in looking at the prolactin and the homocysteine data. There's still more to look at. There's another 5 blood measures that we still haven't written up yet. There's prolactin, telomeres, homocysteine, cortisol, DHEA. Then we also have more frequency bands that we're trying to look at. So look out for the next paper, which is probably going to be late in this year. But this is a really rich data set, and what we've really discovered is that by bringing in as many of these adjunctive measurement strategies, it really helps give us a larger picture of the entire person. Any one of these individual measures in isolation is not terribly useful.
But in conjunction.
In conjunction, when we have this whole person picture, it lets us really gain a better insight to how that person is changing over time.
And what Charlie hasn't said is, and I'm just going to say this really fast, we've just done another big study, a qualitative study, and we're doing a mixed analysis, so qualitative and quantitative, where we've looked at, in depth, at people's behavioral responses across this healing journey. So that's in the process of being analyzed currently. The validation paper is going to be out in the next couple of months. So if you want to know any more, you can go to our website, and there is the most recent papers are there. Thank you.
All right, thanks so much.
Wow, thank you so much. That was incredible. Really appreciate the neurological and biological approach. Bringing together all those 3 things just gives such new perspective and is so important. We are out of time, so we're not going to be able to take any questions. But again, another big round of applause. Thank you again.
Thank you.